So hello guys. So last video we have seen what are BW and what are trims, and we have seen how they are manufacturing also. So we have seen only two processes of manufacturing, right? So there are many of the types of manufacturing processes are also there. Okay. Okay. Let's move on to the next topic. So how we are going to making trims in what software? So generally we are using Catia software for making whatever it is. Okay. So whether it is a plastic part, whether it is a sheet metal part, the Catia is a common. Apart from this, NXCAT we will also use for especially for sheet metal parts, not for interior parts. So the reason behind is the Catia offers more flexible features, more handy tools related to the plastic product design. And similarly, the NX card having the more handy tools related to BAW design. Okay, so apart from this, there is a SolidWorks software, so which is having the surface design tools. Okay, but but it is not offering a good tooling features and good surface tools for making a trims or even BAW. So that's why the SolidWorks is not suitable for surface modeling process. Okay, and of course you have good modeling features in the SolidWorks. So, but it is not suitable for preciseness of this CAT or CAT, next CAT. Okay, so now you're clear about what softwares we are using for what purpose, right? So now let's say about the plastic products, that is not which simply trims. So from this video onwards, so whenever I'm saying the trims, so which means that plastic product. So whenever I'm using the plastic product, which means the trims. Similarly, whenever I'm using the word BAW, it does mean that it is a sheet metal part. And whenever I'm using the sheet metal part, it does mean that it is a BAW. Okay, so this is a thing you have to keep in your mind. So let's see about what is the approach. So okay, I have chosen Catia software for modeling a plastic product. Okay, so what is the approach? The approach is very simple. So the very first step, the class A will be given to you. So who will make this class A? So generally, so in order to answer this question, so I will be making a separate video. What is class A and what is class B and what is class C? I think it will be next video. Okay, we will be seeing what are the differences. What is a class A, what is class B, and what is class C. In that video, you will be understand that. Okay, okay. Let's move on. So approach is very simple. You will be having a class A. So what is class A? We will be seeing in next video. Okay, so you will be given with the class A, and from the class A itself you have to do the part body. So for that the process is called surface modeling. So from the class A you have to do the class B and then class C, and then you can only do the part body out of a class A by doing class B and class C also, right? So the process is very simple. So theoretically it is very simple. Okay, class A will be given. You are giving an offset of class A. Okay, let's take one snap. This area. Okay, let's say for example you have given a class A surface like this. What you're doing, you will be making class B like this at a distance, at a particular distance. Let's say for example 2 mm or something. Okay, so this is your offset surface and this is your parent surface. Okay, so this is your parent surface and this is your offset surface. So the parent surface, which is class A. Okay, from this class A you are developing class B. So this is completely your step. Okay, so then after you have to fill there is a gap, right? So from the class A to class B there is a gap. So the filling process, the gap between the filling of A to B is somewhat known as C surface. Okay, so this is called ABC surfaces. In the next video I'll be explaining what is class A and what is class C in a detailed way. So let's understand this much only in this video. This is enough. Okay, well, uh, see, so let's talk about more about the plastic part and then BW also. Okay, so the class A is given, and okay, I add in the class B and class A and part body also. So what about manufacturing constraint here? So generally the class A, which you are seeing it from the outside, so which is somewhat known as class A, so which is aesthetically good and which will impact your uh, see for, so whenever you're seeing a car you will be what it is rating it based on its appearance, right? So more appearance the car is good, the more impression you got it, right? So that is what the class A, the class A will attracts you when in very first impression, right? So okay, so when you're focusing more on the aestheticness, so what about manufacturing constraint there? Okay, so when you are making a part out of class A, you have to keep in your mind how the part will be manufactured, and that is and we already know the plastic products are always done by injection molding process, right? So in an injection molding process, what will happen? Already told you in the last video. Okay, let's take one more snap. Okay, when injection molding process, what will happen? So imagine if you are having a part like this and you are pouring a molten plastic material inside, right? Okay, okay, wait, I just have forgotten what I'm actually saying. Okay, let's see about class A, class B, class C. Okay, manufacturing constraints. Sorry, let's come back to our discussion. Okay, so you have a part like this and you are pouring a molten plastic part in this way. So that means, so entire thing is a empty space. So you are pouring the plastic molten plastic resin in this way. So that means, so your tooling direction will be like this, right? So in this way only, according to the gravity and all, so this will go and set inside the cavity properly, right? So this is what we can know it as the tooling axis. Okay, in the manufacturing process we will be seeing everything clearly. So for ease of understanding, let's say, so okay, this is enough up to this. Okay, next video I will be saying more about this, no issue. Okay, so we have to see the manufacturing constraints while making the part also. And similarly BAW, when you talk about BAW, the concept is similar but the process may differ. So in the surface modeling, what you do, class A will be given and you are making class B and class C also, and then you are using the part body to fill the material, making ABC surfaces as a boundary, right? But in BAW, so class A will be given and you can get a BAW part by directly thickening class A. Okay, now you may having two doubts here. You can see, So the very first time when I hear about this thing, this manufacturing process and the modeling process, I'm having these doubts. So hope you understand the doubts. So if you're not understanding, so not now, somewhere else, someone else. Okay, we will be discussing all these doubts. Okay, right now I'm just keeping the doubt as it is. Okay, that's up to this video, guys. Thank you.